Now question number 9. A particle is projected from the ground with a velocity of 5 root meter per second at 45 degrees. When the projectile is at the highest point of the trajectory, it splits into two equal parts. One part falls vertically down on the ground. After 0.5 seconds, the splitting. The other part, t seconds after the splitting, falls to the ground at a distance of x meters at point O. Acceleration due to gravity is 10 meter per second square. Then find the t and x value. So this is the question. So here what happens? One body coming like this. What happening here? Here projected with a 5 root 2. One body projected with a 5 root 2 meter per second velocity, and it is making an angle of 45 degrees. That equals to 45 degrees. So what is this? The projected at the highest point. This is maximum height. So this total time is t. What about this? T by 2. And what about this? T by 2. And what about this total range? Okay. Now, what happened? The projected at the highest point of its trajectory splitting into two parts. This body I am taking 2m. So here what happening? Splitting into two parts. So what happens? One part is m. It is falling downward. Another part is coming like this. So this is, in this case, it is not t by 2. Where it is falling, we don't know. The time also we don't know. The distance also we don't know. In this case, this r by 2, this r by 2. But in this case, it is falling from here maybe. So what is asking? To reach from here to here, how much time taken? The time asking. And also, what is asking? Falls on the ground at a distance of x meters. Then x value. This time asking and this total from here to here, x asking. So that is our question. So in this question, what happening? We are applying two concepts. So first, what we are finding? Range finding. Again, what happens in this range? Again, time of flight finding. So what you are given? 0.5 seconds. So from the time of flight only we are deciding after 0.5 seconds where is the position. So first you find the time of flight and range. From that we are getting all information. Again we are going to remaining things. So from this what you are given, after 0.5 seconds this happens splitted image. So this is exploding into two parts. So what is the time? 0.5 seconds. This is 0.5 seconds. First you find total time of flight. Time of flight, that equals to 2u sin theta by g. So 2 into, what is the u? 5 root 2 into sin 45 by g value 10. Now find this value. 2 5s are 10. Root 2 into sin 45, 1 by root 2. Totally 1 second. And all that total. This total time 1 second. After 0.1 second means it is at the maximum height. The information also given maximum height. So here what happens when it reaches here? So first what I am finding? Range. You find the range. What is the range? Range equal to r equals to u square sin 2 theta by g. So what is the u square? 5 root 2 whole square into sin 90 by 10. That is the range. T equal to 1 second means after 0.5 second definitely it is the maximum height. At the maximum height only it is splitting. At the maximum height what is the velocity? only u cos theta velocity is there. At that time only here it is exploding into two equal parts. So here what is the range? That is the value range. This implies range equals to 25 into 2 into 1 by 10. 2 ones are 2 fives are 5 ones are 5. So 5 meters is the range. So actually what happening? If it is not explodes as it is comes, it falls at 5 meters from the projection point. So but here what happened? It is exploding into two components, two parts. So before explosion, what is the velocity? U cos theta. So you apply law of conservation of linear momentum. We are applying law of conservation of linear momentum. What is the law of conservation of linear momentum? m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. What is this name? Law of conservation of linear momentum. Law of conservation of linear momentum. Before collision total momentum equals to after collision total momentum if external net force is 0. So before explosion what is the total mass? 2m I am taking. What is the velocity? U cos theta. After explosion what happening? One part m, another part is another also m. Freely falling. So vertical velocity what? 0. It is vertically falling, freely falling. So at a particular position it rests only after exploding. So coming downward with what is the velocity? 0. Another part m. Here what is the velocity? That velocity I am taking as v. That velocity I am taking as v. So from that what I am getting? Velocity of that particle getting. Again from that we are getting time. So what about this velocity? This implies 2mu cos theta that equals to mv. mm cancel. Now what is the velocity? 2u cos theta. What is the u? 5 root 2 into cos theta. Cos 45. Cos 45 1 by root 2. So v equals to 10 root 2 into 1 by root 2. What is the velocity? 10 meter per second. Another particle velocity 10 meter per second. So that is the second particle velocity. Now what happening here? That is the velocity. So from here to here we are finding displacement. What about this? I am taking horizontal components, not vertical components. Before collision, total momentum horizontally, u cos theta. After explosion, one is at rest. Freely falling means rest only. Remaining v. Remaining what velocity? I know. Here to here, t by 2 means remaining also t by 2 only. Then, if it is 0.5 seconds, what about remaining part? 0.5 seconds only. So, in the second journey, total time of flight 1 second given. Here to here 0.5 means remaining also 0.5. So what is the remaining time? After 0.5 seconds, it reaches the ground. Horizontal velocity 10 meter per second. Time we know. Horizontal component constant only. So that is uniform velocity. Uniform velocity into time gives the displacement. Displacement equals to velocity into 10. So v into t. So 10 into 0.5. Now what I am getting? 5 meters. So after explosion, it falls at the 5 meters. Already here what is this? What is asking? That only. That is 5 meter distance. Now what is asking? This is asking totally from the initial position. This 5 meters completed. So from the projection point where it is falling asking. So what is the range? Initially what we have got range? First range what we have got? In the range of only this R by 2 I had taken. So first what we had got range? We had got that range equals to 5 meters got. Range equals to 5 meters got. So here what R by 2 and here what X. So from the projection point to here this. Totally what happens? Here R by 2 and this is what totally here to here X. So R by 2 plus X. Range what we got 5. So 5 by 2 plus X. So that equals to 2.5 plus 5. Totally 7.5 meters. Due to this only I had found initially range. This is T by 2. This is T by 2. This is R by 2. This is R by 2. This is maximum height. This is 0.5 seconds. This is 0.5 seconds. For general condition. But here what happens? After explosion some change happens. So up to explosion this only, no? R by 2 only, T by 2 only. Here T by 2 same only. But what happens? Displacement changing. So what is the displacement? That we are found. That we are adding to R by 2. So totally I am getting from the projection point to where it is falling, that is coming. If it not explodes, as this comes here only. R by 2, R by 2. What is the R? 5. So here what? 5 minutes only it is falling. But it is falling some more distance due to explosion.